First hill on a roller coaster, you often hit a little valley here before going back up onto another hill. But when you get to the bottom of this valley, you feel like you're being squished into your seat as you're about to go back up. The question is, how many G-forces are you feeling if the radius of this circular part of this valley here is 20 meters, and you're doing 15 meters per second at that point? How many G-forces are you feeling? Now, G-forces is just a multiple of normal gravity. So 9.8 meters per second squared is the acceleration if you're feeling 1 G-force. So now we just need to basically find what is the G, what is the acceleration that you're feeling, and then we can calculate the G-forces. So here's what we end up with. First things first, we have to write our equation for centripetal force. Now I've got two forces, one going towards the center of the circle, the other one going away. So my equation becomes the normal force is positive because it goes towards the center, and gravity is negative because it's going away from the center. And those two things together give me my centripetal force. Now what we're going to do is we're going to solve this equation or set it up for the normal force because that's what you are feeling on your body. That's how squished into your seat you are. So I get the centripetal force plus force of gravity when I add that to the other side. Now what we need to do is we need to say, okay, what is the centripetal force and the force of gravity when they're put together? Now we don't have mass, but that's okay. We don't need it. So I've got the normal force is going to equal, here's centripetal force. I'm going to write the equation mv squared over r because I have r and I have v. So that's why I chose that one. I've got the things that are in it. Plus the force of gravity, which is mg. Now I'm going to plug in some numbers. I know I do not have the mass, but I'm not needing the mass. I'm not looking for the actual force. I'm looking for more the acceleration that this person is feeling, the acceleration towards the center. So what exactly is it that you're feeling on your person at the very bottom of this hill? So if I plug in some numbers, I have v squared over r. So that would be 15 meters per second squared over 20 meters plus the mass times 9.8 meters per second squared. When I plug that into my calculator, what I'll get for this first term is that mass is getting multiplied by 11.25 meters per second squared. And on the right here, this mass is still getting multiplied by 9.8. So what you can do is we have two like terms. We have a mass here, we have a mass here. We can add these two together. And what I get is that the normal force feels like it's 21.05 meters per second squared times the mass. So this is what it feels like the acceleration due to gravity is at the bottom of this hill. Now we just need to find that as a multiple of 9.8. How many times 9.8 is 21.05 meters per second squared? Well, all we have to do now to find what multiple of 9.8 it is divide by 9.8. So I'll do that up here in the top right corner. 21.05 meters per second squared divided by 9.8 meters per second squared is how many G's of force I'm feeling, how many times gravity I feel like the force is. And when I divide that, I feel like it's 2.15 G's. That's how many G's of force you're feeling. So you would feel like you weigh 2.15 times however much you weigh.